Okay, so in this video, I'm going to go over two questions based on lesson 3, but then after that, I'm going to make another video of two more examples in case you need two more examples to help you. Then I'm also going to go through this week's practice and just talk about a couple questions that we've put up there that I want you to know about. So if you feel confident in this video afterwards, you can go ahead and start the practice. If not, there's going to be a second video for you to look at to make sure that you are getting what you need to. Okay, so you've worked a lot with exponential functions, and we've been this week looking at percents versus or factors versus rates, and kind of knowing the difference between those and how we can derive them from a description. So what we're going to do in this video is look at application problems and do the same sort of thing. So I'll start off with the first example. It says a population of African white rhinos is in danger of going extinct. The population starts with 6,000 rhinos in the year 2008 and decreases exponentially at a rate of 20%. Complete the table below to show how many rhinos are left each year. So definitely grab your calculator for this because we're going to be working with percents and everything. So the first thing I want to point out is that it says at a rate of 20%. So remember when we're writing equations, we need to have the factor. So we need to convert that rate into a factor. So 20% is the same thing in decimal form as 0.20. Okay, so that's the factor we're going to be working with, but it's decreasing by that. So every time, so it's a decay function, every time it's going down, it's decreasing by 20%, which means I'm actually taking only 80% of the number before it. So if I'm taking 80% of the number before, it's decreasing by 20%. So another way to get that number is to take this factor and do 1 minus 0.20, which will actually get you the decay factor for this question to be 0.80. Okay, so each time I'm going to take that initial value and I'm going to take 80% of the original value. So it's decreasing by 20%. So if I start off with 6,000, and if you see the tables going by years, and you're going to see this in your practice, but it's giving us a start rate of 2008. So I'm going to consider that year 0 and then kind of start from there. So that's why the years are in parentheses there. So if I take 6,000 and I take 0.8% of that, or 0.8 of that, I get 4,800. And I'm doing my best to kind of write that in there. So then I take 4,800 and I take 80% of that, which is going to be 3,840. And then I multiply that by 0.8 and I get 3,072. And multiply that by 0.8, I get 2,457.6. And multiply that by 0.8, I get 1966.08. And then I multiply that by 0.8 and I get 1572.864. So I've just filled out that table using what I know I want to take 80% of the original value, which means it'll decrease by 20%. So if I go down here to the first question, it says write an equation for the situation to show how many rhinos there are for any number of years. So I want to look, it didn't give me any variables to use, so I can just use y and x. But x is going to represent the years and y is going to represent the number of rhinos. So to find the number of rhinos, I'm going to take the initial value, which is 6,000 in this case, and I'm going to multiply it by a decay factor of 0.8 because it's decreasing by 20. And I can put x as the exponent there. So that is the equation. In a multiple choice, you might see it written as y, I'm going to write it a little smaller here, 6,000 times 1 minus 0.2. That's just the same thing as we did. We just already did that up there. So you might see it in a multiple choice. You have to know that these two things are the same. Okay, so then in this, it says use your equation to determine how many rhinos are left in 2018. So let's go back up to our table. 2018 from 2008, is 10 years. So that is 10 years. So my X value is actually going to be 10 because it's 10 years from 2008, and 2008 was year 0. So I'm actually going to plug in 10 for where X is in my equation so I can solve and figure out how many rhinos there are. So Y should equal, I'm going to figure out what Y is when I do 6,000 times 0.8 to the 10th power. So if I do that in my calculator, I'm going to do 6,000 times 0.8 caret 10th power. And you can round to the nearest, we'll say 10th. So there are going to be Y equals 600, and actually we should probably round to the nearest whole because they're rhinos. You can have half of a rhino, so about 644 rhinos will be left in 2018. So all I did was use my equation, and it helps me go faster versus keep going with this table and keep doing 0.8 every time. So that is the first example when you have a table. The second example is if maybe you don't have a table. So I'll use green for this one. So it says write an equation for a collection of snow globes that has an initial value of 750 and it grows at a rate of 25%. So when you're growing at a rate, again, this is a rate, so I need to figure out the factor. So if I convert this to a decimal, I get 0.25. But if I'm growing, I want to take 750 and I want to add 100% of the original value plus 25% if I want to increase it by 25%. So this 1 represents actually 100%, and then I want to add 25% more. So this is going to be the growth factor that I use when I write my equation. So I'm going to erase this here. Your equation should be for this one, Y equals 750. That's your initial value. And your growth factor is going to be 1.25 to the X power because you want to grow it by 100% plus 25% more. So you got to add those two together to make sure that you're growing. Remember, if I just put it as 0.25, that would be actually decaying because it's less than 1. So you want to make sure that you represent growth. So that is writing the equation. The next thing it says, use your equation to show how much snow globes will be worth in 6 years. So Y is snow globes, X is time. X is usually always time. We're going to plug in 6 years for X. So you should have your equation look like 1.25 to the 6th power. And then I can go ahead and type that in. So I'll get Y equals, so I'll do 750 times 1.25 to the 6th power. And since we're talking about worth or price, I'm going to round to the nearest hundredth. So I'm going to erase this stuff on the side. Your answer is going to be $2,861.02. So that's how much snow globes will be worth in 6 years. And then if I go down here, it says between what whole number of years will it take for the collection to have a value of 4,000? So what you would want to do here is you're going to want to go to Desmos or use your graphing calculator and type in the original equation. And then look for when, what number years the collection will be 4,000. So if I do this and I go to my internet, so I'm going to go to my internet here and I'm going to go to Desmos and I'm going to type in that equation that I had. So Y equals 750 times 1.25 to the X power. And if you remember, you can look at the table here and look for when it'll reach 4,000, so you can keep adding numbers here. So it'll be between 7 and 8 years. So that would be my answer for that one. So you can say between 7 and 8 years. So if it wants you to use your table, it'll say, between what 2 years. If it wants to use your equation, you should usually say use equation. So those are the two examples I'm going to go over in this video, and then the next video I will go over 3 more examples.